My research expertise is in an area of discrete math called graph theory, which is the study of networks. And one of the major themes in my research is understanding how things like information, diseases, or rumors can spread through a network. I've been at the University of Manitoba since 2015. And it's a dream job. I love getting to think about my favorite subject every day and interact with fantastic colleagues and the wonderful students that we have here. I think one of the things I love the most about the kind of research I do is that a lot of even really complicated and difficult research problems in discrete mathematics can be explained to just about anybody. The study of networks shows up in everyday life in many different ways, from the study of social networks to computer algorithms, things like finding directions on Google Maps. I had a recent research project with a group of my postdoc, who was JD Nir at the time, and a couple of undergraduate research students, Kellough and Hritik Punj. And it was about a problem called graph burning. And they've modeled it thinking of a fire spreading through the network versus this viral marketing campaign. Either works. And so the problem that we were interested in working on is what happens in that kind of context if the network is evolving and growing and changing over time, as real life networks do. We decided to study this problem was to set up an adversarial game situation. So we said, okay, player one is the marketer who wants to reach as close to 100% of the population as they can. And their adversary, player two, is the person building the network. And so they're choosing how to design the growth of the network to try to thwart the marketer's efforts. And so what we were able to do was to characterize what happens in that kind of setup depending on how fast the network is growing. So if I tell you how fast the network is growing, you can understand whether or not the marketer can succeed or if they're going to be thwarted in the worst case scenario. And what was really interesting was there were some very paradoxical situations we found where you could have two growing networks where in the more slowly growing network, the marketer actually sort of failed to reach 100% of the population, or nearing 100% of the population over time. And it had to do with how the growth fluctuated. So that was something really interesting.
I have completed a couple of research terms here at the University of Manitoba, one with the Department of Mathematics and one with the Department of Computer Science, both funded by the undergraduate research awards that the University of Manitoba and the Faculty of Science offers to encourage the undergraduate research. So for me, the main focus has been on graph theory and also like how things spread in a network. For now, the cases that we studied were very limited, and we were just trying to understand the problem a bit more. These kind of problems are like really close to what happens in real life. So imagine misinformation being spread in a network. With the advent of social media, the number of devices are increasing, so the network of nodes that we have where information spreads is also growing. So we are trying to understand how that spreads, and is there in any way can we stop it or promote it, depending on what we are trying to do. If I were to choose something, I would just study this problem in general and have a solution for the whole general problem.
In terms of challenges in my field, one of the aspects of research mathematics is that it's highly collaborative. There's something really magical about people in the same room together working at a blackboard or a whiteboard. So building collaboration networks is incredibly important, and that's something that's a big challenge to people who are getting started in the field, graduate students needing funding for travel, to go to conferences, for example. When things like global pandemics impacted travel, that was very hard on mathematicians. So some of the ways I look at trying to solve them for my students, I try to be really proactive about finding ways to get them funding to go to conferences. And for myself, I'm finding I try to be very careful about making sure that I find good opportunities to travel, to go to conferences, to collaborate people, and try to figure out which ones will have the most bang for the buck. Thinking about the future, one of the things that I really love about research is learning new things all of the time. So in my wildest dreams, in the future, I'll be working on something I have no idea about right now. And that's something I really love, is finding new things to learn about and finding ways to connect really different areas of mathematics that I've worked on.